All right, so 7.1, guys, talks about, let's see. Okay, talks about introduction to hypothesis testing. So it says here, a hypothesis test is a process that uses sample statistics, like our sample mean, sample proportion, sample variance, to test a claim about the value of the corresponding population parameter. Okay, so let's take a look here what we got. First example, they're right up there. Okay, so it says a car manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. To test this claim, a sample would be taken. Okay, using what you've learned from previous sections, you can determine if the sample mean differs enough from the advertised mean. If so, you can conclude that the advertisement is false. Okay, so let's think about what they're saying here, right? There's a car manufacturer says, look, the new hybrid car gets 50 miles per gallon, right? This is what their claim is, right? So we would say, okay, you know what? Maybe we'll work for like Consumer Reports or something like that. Let's take 10 of these cars, right? And let's drive them for a month. And let's figure out what kind of mileage we're getting, right? Or let's take 50 of these cars, or let's take 100 of these cars. So let's test them, right? And then what we're going to do, we're going to find the average, and we're going to say, okay, is that close enough to 50 miles a gallon? So we can determine whether or not they're being accurate or they're, poking in the eyes a little bit, right? Okay, so guys, we have something called stating a hypothesis. It says a statement about a population parameter is called a statistical hypothesis. There's always going to be two types of hypotheses, guys. The first one is something we call the null hypothesis. And then we have what we call the complement of the null. The complement of the null is what we call the alternate hypothesis, okay? And either one of those two can be the claim, okay? So the next thing is, how do I know which is the null hypothesis and how do I know which is the alternate? The null hypothesis, guys, is going to have some kind of a statement about equality. So I want you to look at these three symbols right here. Well, we obviously know that the last one here is equals. We know what that is, right? Equals, okay? Look at these two here. Look at the first one. The first one says less than or equal to, right? And the other one says greater than or equal to. So the null hypothesis is either going to say something is equal to, or it's going to say something is less than or equal to, or greater than or equal to. But the whole point is there should be some kind of equality in there, okay? Something about an equal to part. That'll be my null hypothesis, okay? Now, the alternate hypothesis is going to be the complement of the null. Good. So this one right here, guys, yeah, that's going to be less than or equal to. And then this one here, good question, greater than or equal to. Okay. There you go, right? The Pac-Man eats a bigger number. And I don't know if you guys learned it like this. I want to say this is how I learned it. Less than, which way is that little arrow pointing? Yeah, oh, look, there you go. It looks like an L, right? That's how you learned it. And it's pointing to the left. So less than is to the left, greater than is to the right, okay? So guys, the alternate hypothesis is the complement of the null, okay? And it says it must be true if H0, the way we read this little H0, oh man, where's my eraser? Here we go. So a lot of times the way this symbol is read, like if you were to watch a little video that comes with like my math lab or something like that, they're going to read it as H naught. I'm going to call it H0 because it looks like a zero to me. Okay, so I'm going to call it H0. Okay, so it's saying that the complement of HA, which is the alternate hypothesis, is going to be the complement of the null. And the alternate is going to be true if the null hypothesis is false. And it always contains a statement of strict inequality. So look what this means. Greater than, less than, what does this mean? Not equal to, right? Okay, so it even tells me right here, H0 is read as H sub 0 or H naught. I'm just going to call it H0. And HA, it says, is read as H sub A, sub because it's down there, right? I'm just going to call it H0 and HA, okay? All right, so some possible hypotheses regarding claims about the mean mu are shown below. Regardless which you use, You always assume that mu is equal to k and examine the sampling distribution on the basis of this assumption, okay? So all it's telling me, guys, that these are all possible null hypotheses, okay? So let's take a look at the first one, okay? The first one right here. Look what it tells me. The null hypothesis, it says the mean is less than or equal to k. Whatever that number happens to be, right? Suppose the mean is less than or equal to, so let's make it up, 7. Well, if my null hypothesis is the mean is less than or equal to 7, then the alternate is going to say it is greater than 7. It's going to be the opposite, right? Okay. And the next one here, the mean is greater than or equal to, I'm going to make it up again, 7, right? So if the mean is greater than or equal to 7, what is the opposite of saying something is bigger than or equal to 7? It has to be less than 7, right? Same thing over here. The null hypothesis says the mean is equal to 7. Well, what's the opposite of it being equal to 7? It's not equal to 7, okay? All right. So let's take a look here at sort of the first problem we have, and it's asking us to write the claim as a mathematical statement, state the null and alternate hypothesis, and identify which represents the claim. Okay, so I take a look here. I'm going to just read it. It says a water faucet manufacturer announces that the mean flow rate of a certain type of faucet is less than 2.5 gallons a minute. Okay, so guys, remember what the symbol we use for the mean? We use that funny looking mu, right? The mu. Okay, look what it's telling me. It says the mean flow rate, that's why I'm using the mu, is less than 2.5 gallons a minute. So I'm going to go like this. Less than 2.5 gallons per minute. Okay. Now, guys, do you all agree with me that that is what they are claiming? Okay, that's my claim. Okay. All right. So the complement of that, what is the opposite of saying something is less than 2.5? It's not only greater than, guys, but greater than or equal to, right? 2.5 gallons per minute. Okay, so we got that part now. Now there's only one other part we got to figure out. The other part says which one is going to be the null and which one's going to be the alternate. Guys, the null will always have the one that has the equal to part. Okay, and the little symbol that we use for the null hypothesis is at H0. Okay, so this is my H0. Now think about what we call the other one. One is called the null, the other one is called the what? The alternate. So then the other one is going to be my HA, right? That'll be my alternate, okay? Guys, I'm going to do a bunch of these problems here. In your homework in my math lab, you're going to have problems that are very similar to this, okay? So let's take a look at the next problem. That's all we're doing for these problems, guys, okay? They're not asking me to do anything else. It's just basically like an identifying type problem, okay? So look at problem number 2. It says a cereal company advertises that the mean weight of the contents of its 20-ounce size cereal box is what? More than 20 ounces. Okay, so what they're saying is the mean, right, which we're calling mu. More than, guys, everybody agree more than is greater than? Greater than 20 ounces, right? Do y'all agree that that is their claim? That's what they're saying, right? They're saying that if you take this box of cereal, I know on the package it says it's 20 ounces, but they're saying it's actually more than 20 ounces, right? Okay, so this is their claim, right?
So the claim will never be equal to?
Not that the claim won't be equal to, but that's what the sentence is stating, right? They're stating that it's more than 20 ounces, right? They could have said it's equal to, right? So guys, what is the complement of that? What's the opposite of saying something is greater than? Less than or equal to 20 ounces, right? Okay. Right? That sounds more realistic, right? Okay, now guys, remember, now the only other part we got to do is we got to figure out which is the null and which is the alternate. The null is always going to have the one that has the equal to. And the little symbol we use for the null is the H0, right? The H0 is always going to have my equal to part, right? So if this is my null, then the other one has to be my HA, right? My alternate. So far, so good? Okay. Alrighty. So, guys, guys, you can see problems, again, still sort of talking about the same thing here, okay? Let's take a look. It says, a university publicizes that the proportion of its students who graduate in 4 years is 82%. Okay, so guys, instead of talking about a mean, look what we're talking about. We're talking about a proportion, okay? So it's telling me that the proportion, I know it's been a long time since we've done this, but I don't know, remember, this was like maybe the second or third week of school. Do you remember when we did like the percent problems and we said, what is and? Does anybody remember what the word is meant? Equals. Okay, guys, my question to you, how would I write 82% as a decimal? 0.82. Okay, so I want to point something out. It says that the proportion is 82%. So Isaac, you were asking me this a little while ago, can that be the claim? Yeah, it can. The equal to can be the claim. That's what they're saying at this point. So guys, let me ask you a question. What is the complement of being equal to? What's the opposite of being equal to? Not equal to. So look, we're going to go like that. A little equal to, a little slash through it, 0.82. Okay. Now, the only other part we got to do is, which one is the, I'm sorry.
Those still have nulls?
Yeah. They're still going to have nulls and alternatives. So remember, the null is the one that has the what? The equal to. So here's my equal to. That's going to be my null. That's going to be my HO. The other one will be our HA. Okay. Alrighty. Let's take a look at number 4. It says a realtor publicizes that the proportion of homeowners who feel their house is too small for their family is more than 24%. Okay, so look guys, we're still talking about what? Proportion. So I'm going to put P. What does more than mean? Greater than 0.24? Okay, this is the claim. This is what they're stating. Okay, so my question to you, what is the complement? What's the opposite of saying something is greater than 0.24? Very good, less than or equal to. So guys, a lot of times people just want to say less than, but it really is less than or equal to, right? Okay, then remember what we said? That as long as we have the equal to, that's going to be our H0, which we call the null hypothesis. And the other one will be the alternate, the HA. Alrighty. So now let's see what else we got here. It says a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, so proportions, we're talking about P. Y'all remember what is meant again? Equals 0.61. Again, guys, this is my claim. Okay. So what's the opposite of saying something is equal to? Not equal to 0.61, okay? Y'all know which is the null? The top one because it has the equal to, so this is going to be our null hypothesis, and this is going to be our alternate hypothesis, right? So far we're doing okay? Good, good. Okay. So, the next part here, guys, talks about types of errors and levels of significance. It says, regarding which hypothesis is the claim, you always begin a hypothesis test by assuming the null hypothesis is true. A sample is then selected, and when you perform the test, you make one of two decisions. We either reject the null hypothesis, or we fail to reject the null hypothesis, okay? And it says, keep in mind that because you're dealing with only a sample, you must accept that your decision could be incorrect. And there's two types of errors, okay? So the first type is called the type 1 error, and it says it occurs if the null hypothesis is rejected when it's true. And the second type is called the type 2 error, and it says it occurs if the null hypothesis is not rejected when it's actually false, okay? And so guys, what we have here, we have a little table, and it kind of gives us the part where we can find our type 2 error and our type 1 error. And I think the easy, or a little bit an easier way to sort of to understand this is if you do me a favor and turn to the next page. So, I'm sorry, real quick guys, before you turn to the next page, do you see right here where it says we're going to reject the null hypothesis? And then over here, do you see where it says we're not going to reject it? Okay, a lot of times people say, well, hold on, if you're not going to reject it, does that mean that you're accepting it? And it doesn't necessarily mean that, okay? What I want you to do, take a look at the next page up here. And it says, look, hypothesis testing is sometimes compared to the legal system that we use here in the United States, okay? Under this system, the steps are used. So a carefully worded accusation is written. Okay, Omar, we are accusing you of robbing the Bank of America on the corner of Pecan and Ware Road. That's a very, right? I'm being accused of something, right? Bank right here. They said you came in, they said you gave a note to the cashier, I'm robbing this bank. Okay, that's the accusation. Because we're in the United States, what do we know first, guys? I'm what? I'm innocent, right? Doesn't the prosecutors, don't they have to prove without a reasonable doubt that I'm guilty? Okay, now guys, you go to Mexico, is that the same scenario? You are guilty and you have to prove you're what? You have to prove you're innocent, right? So if we were in Mexico and they said, Omar, you robbed this bank over here on this street and I'm being accused, the assumption is I'm guilty. I have to prove that I didn't do that, right? That it was not me. Isn't that a much more difficult scenario, right? Aren't you glad we live over here, right? Not on the other side, or in other countries they do the same kind of thing, right? Okay, so it says the burden of proof lies with the prosecution. If the evidence is not strong enough, there is no conviction. A not guilty verdict does not prove that a defendant is what? It doesn't prove that I'm innocent, right? So guys, if I go to trial, and at the end of the trial, the jury says, or the judge says, not guilty, it doesn't mean that I'm innocent. It just means that they didn't do their part in proving my guilt. Does that make sense? Okay. So it says the evidence needs to be conclusive beyond a reasonable doubt. The system assumes more harm is done by convicting an innocent, which is a type 1 error, than by not convicting the guilty. Okay, that would be a type 2 error. And it says the table to the left, I actually put it down here. And so here we go, guys. All I'm going to try to do here for us is try to make this kind of look like what I had on the page before. So on the page before, do you see how we had this reject the HO and do not reject the HO, and the HO is true and the HO is false? I'm just going to kind of write some of that stuff in right here. So this is going to be reject the null hypothesis, and this is going to be do not reject the null hypothesis, right? Innocent is that the HO is true, okay? And guilty is that HO is false, right? And guys, just to kind of give you an idea, right? What is my HO? What's my null hypothesis? In this particular case with like the guilt type thing, the HO is that I am what? I circled it up here for you. I'm innocent, right? Okay, so think about it this way. If that's true and I'm innocent, and they rejected it, they said that I'm not guilty, then justice was served, right? But if I was innocent and they did not reject the null hypothesis, right? And they said I'm guilty, this would be a type 1 error. So even though I didn't commit the crime, they still convicted me. Does that make sense? And they're saying, that at least in the legal system, that's a worse mistake than saying, okay, I actually robbed the bank, right? So suppose I actually really did do it, but the prosecutors couldn't prove it, and they let me go, right? The way the legal system here works is we would much rather have that than by putting innocent people in jail, okay? All right, so what we're going to do, we're going to go to the problem down here on the bottom. Let me zoom in a little bit so we can see if we can figure this thing out. Okay. It says, a company specializing in parachute assembly states that its main parachute failure rate is not more than 1%, okay? It says it's not more than 1%. So the percentage that they're talking about, guys, if it's not more than 1%, what are they saying? What does not more than 1% mean? Is it less or only less or less or equal to? Less than or equal to 1%, guys, as a decimal, 0.01, right? Okay. So now let's find the complement. What is the complement of less than or equal to? Greater than 0.01, okay? So look what they're saying. The parachute failure rate is not more than 1%. This is their claim, okay? This is the claim, all right? Now, which is my null hypothesis, guys? Which is my HO? The top one, right? This is going to be my HO. This is going to be my HA, okay? All right, so give me 1 second, guys. I'm going to pause this real quick because I have another handout that I want to pick it up. Okay, so guys, look what it's asking me for. It says, we're going to perform a hypothesis test to determine whether the company's claim is false. Identify the null and the alternate hypothesis and label the claim, which we already did. We've done this part here. Okay. And let's see. Write possible type 1 and type 2 errors. Which one is more serious, right? Okay, so let's take a look here. Where do I have my notes? Okay, so a type 1 error, guys. Right here, type 1. So that looks very messy. Type 1 error. Okay. If you look at the handout that I just gave you, right, which I have it right here as well. Let's see. Okay, a type 1 error says, what occurs if the null hypothesis is rejected when it's true? Okay, so I'm going to come back over here. So look at what the null hypothesis is, right? The null hypothesis happens to be their claim also, right? And their claim says that the failure rate is less than 1%, okay? So again, just to make sure I understand what we're doing here, I'm going to come back and look at, here we go. Type 1 says, if the null hypothesis is rejected when it's true. So we're rejecting this. We're saying that's not true, but it happens to be true, right? So what would that mean? That would mean that, say, I don't know if you've done this, guys. I probably would never do it, but I'm not going to go skydive or anything crazy like that. It's just not my thing, okay? But suppose maybe Rafael decides, you know, he likes doing that kind of thing, right? Thrill seeker, all that kind of good stuff. All right. And suppose Rafael finds about this and he says, you know what? I'm going to reject that. I don't believe him, right? I don't believe that their failure rate is less than 1%, when actually that's what it is, right? And so all that means is maybe he stops going to do skydiving. Does that make sense? Because even though the parachutes are pretty safe, he doesn't believe it, or they reject it, they don't believe it, even though it is true, right? So type 1 claim would be, we're going to reject the claim, even though, even though it's true. Okay. Now let's see if we can figure out what a type 2 error is. Okay. So guys, again, if I just switch back to the handout that I gave you right now, okay, let me close this one up. Here we go. Okay, type 2 error says it occurs if the null hypothesis is not rejected when it's false, right? So if I come back over here, so this is false, right? The null hypothesis, suppose that's false, meaning that the failure rate is more than 1%, right? But we don't reject it. So what does that mean? Maybe Rafael says, hey, you know what, man, I've been doing this skydiving for a good while, or jumping out of a plane for a good while, doing the parachute, it's good, right? And suppose for Alexa say, hey, you know, I want to go too. Isaac says, I want to go too. You get a whole bunch of people to go do it, but the failure rate is actually more than 1%. Somebody told you go out there, you put the thing on and you jump and you pull a little cosa. And what happens? It doesn't work. Which was worse, guys? Look, think about the two scenarios. Remember we said the first one, Rafael starts getting real skeptical. Even though their parachutes are safe, he just doesn't go anymore. Does anything bad happen? No. But if their failure rate is actually more than 1% and more people start skydiving, right? Or you still have the same people skydiving, somebody jumps out the plane, pull the thing, it doesn't holla, right? Well, so there you go. Okay, so type 2 error, guys, all I'm going to do, I'm just going to come back over here and just copy down what I have right here. Occurs if the null hypothesis is not rejected even though it's false, right? Or when it's false. So we do not reject the HO even though the HO or the null hypothesis is false. So in this case, I would say a type 2 error is probably more serious, right? That's probably more serious. And guys, remember when we talked about the problem over here with the guilt and the innocent, right? And it says, look what it says right here, right? The system assumes that it's doing more harm if we commit a type 1 error than we do a type 2, right? So we don't want to be locking up innocent people. The system assumes it's better to let somebody guilty go free than to have a bunch of people who are not guilty in jail, or worse, death row, something like that. But also when it comes to this problem here, the type 2 error seems to be the more serious of the two, okay? Okay. So now let's take a look at the next part here. It says, how do we know whether or not we're going to reject the null hypothesis? And it says, this depends on whether you get an unusual sample statistic from the sampling distribution. So guys, when we've talked about unusual, we talked about like the z values that are unusual, but we said that when the probability of something is going to be smaller than 0.05, okay? Let's see, there's always a possibility that we'll reject a null hypothesis as true. To decrease this, we can lower the level of significance. All right. So it says the level of significance is your maximum allowed probability of making a type 1 error. We call this alpha, and it's a little a that looks kind of like that. And then it says the probability of making a type 2 error is denoted by beta, and it's just the Greek letter kind of like for B, and that's what it looks like right there. Okay. So I'm going to just kind of keep reading a little bit here. So it says, after stating the null and alternate hypothesis and specifying the level of significance, we're going to obtain a random sample. We're going to calculate sample statistics using X bar or the p hat or the sample standard deviation. I'm sorry, the sample standard deviation squared. According to the parameters of the null hypothesis, let's see, the sample statistic is called a test statistic. And when we assume, we're always going to assume the null hypothesis is true, the test statistic is converted to a standardized test like a z-score or a t-score. We're not going to do this one here, guys, because we skipped 6.4, but it's okay. And we'll be making a decision about the null hypothesis, okay? So I'm going to kind of walk you through some of the problems here. It says if the null hypothesis is true, then a p-value or a probability value of a hypothesis test is the probability of obtaining a sample statistic with a value as an extreme or more extreme than the one in the data sample. Okay. So there's a lot of reading here, guys, but we're going to figure out, we're going to do some problems in a minute. Okay. So the way we're going to be doing 3 types of tests, guys. One of them is called left tail test, one's called right tail test, one's called two tail test. And the way we know whether or not I'm doing a left tail, right tail, or two tails test, I'm always going to look at the alternate hypothesis. Guys, remember the alternate hypothesis is the one that we call HA. Okay. So I want you to take a look right here. We're talking about a left tail test. And it says the alternate hypothesis, HA, contains the less than inequality symbol. So if you look right here, do you see my HA? Do you see how it's pointing to the left? That's how we know that that's going to be a left tail test, because it's pointing to the left. And it's always going to be the HA, guys. Always the alternate hypothesis, okay? Now, look at the next one. It says right tail test. Okay, so right tail test. First thing I'm going to do, I'm going to look for my HA. Here it is. It's pointing to the right, and that's what we call that a right tail test. Okay. Now, two tail test. So when the alternate hypothesis has the do not equals, then that's going to be a two-tailed test. Think about it this way. If it's not equal to this part in the middle, then that means it would either be equal to the stuff on the left or the stuff on the right, okay? And each tail is going to have half of whatever that p-value is, okay? And I'm going to show you how we're going to figure these things out in a minute. Okay. All right. So let's take a look at the next problem here. It says for each claim, state the HO and the HA, the null and the alternate, and then determine whether the hypothesis test is a left tail, right tail, or two-tail test. Sketch a normal sampling distribution and shade the area for the p-value. Okay, so guys, we actually did part of this earlier. Look what it says here. It says the water manufacturer announces that the mean flow rate is less than 2.5 gallons a minute. Okay, so what symbol do we use for the mean? But for the mean, though, the little funny looking U, right? The mu, okay? And it says it's less than, 2.5 gallons per minute. Okay. Do y'all agree that that is our claim? Okay. So what's the complement? What's the opposite of saying something is less than 2.5? Greater than or equal to 2.5. Okay. Now, the other part, guys, just like we did earlier, do you remember which is my HO, which is my null, and which is my HA? HO is the bottom one, good. Okay, there's my HO. And then our HA would be the one on top, right? Okay, now all we're going to do, guys, we want to figure out, it's going to be a left tail test because we're looking at the HA, right? We're looking at the HA. So all we're doing here, guys, is we're going to find a p-value.
Well, just because you use the word less, wouldn't that indicate it's a left?
Well, not necessarily, because remember, I'm looking at the alternate, right? It happened to be my claim, but it won't always be my claim. You know what I mean? So I have to figure out which is my HO, which is my HA, and then whatever the HA is. And that's what we're doing here. So it says, sketch a normal sampling distribution and shade the area for the p-value. That's what we're looking for right there. Okay. No, other than this right here, that's all we're really doing. And this is going to be my, it's a horrible looking P. It's supposed to be a P. Right? That's my p-value right there. Nothing like that, not yet. We're gonna, so guys, chapter 7 kind of breaks it down into very kind of small pieces, okay? So let's take a look at the next one. It says, a cereal company advertises the mean weight of the contents of its 20-ounce cereal is more than 20 ounces. Okay, so again, mean weight is going to be mu is greater than 20 ounces. Okay, this is our claim. Okay. So what's the opposite? What's the complement of saying something is greater than? Less than or equal to 20 ounces, right? Okay, y'all know which is the HO? The bottom one is our HO, okay. The top one's going to be our HA, okay. And so, guys, because we're looking at the alternate, which way does that arrow point? It's the right tail test. So this is how we know we have a right tail test, right? The one on the top was a left tail. That's right. But the one thing I have to know, Rita, I always have to look at the HA one, right? So it won't, I'm not going to look at this one. I'm going to look at the HA. So which way the HA arrow points, that's how you'll know which one to do. Yes. And this is my P right there, right? It's going to be the probability under that, like what's the area under that curve? Yeah. Okay. So guys, let's take a look at the next one. We're going to keep doing the same kind of thing here. Okay. Let's see, a university publicizes that the proportion of its student who graduates in 4 years is 82%, okay? So P, everyone agrees, equal to 0.82? Okay, wasn't that our claim? Right? And so the complement is going to be what, not equal to 0.82? All right. And so from here, let's see, which is the HO, guys? The top one. That's my alternate, that's my null hypothesis, and this is my alternate, okay? So guys, look what we're going to do here. That's going to be the one that I'm going to figure out now, right? If it's not equal to 0.82, right? If it's not equal to 0.82, then I'm looking at a two-tailed test, right? Because if it's not 82, it's going to be whatever's left over, right? So this is going to be a two-tailed test.
What's that probability on each side?
Always, if it's a two-tailed test, yes. Yeah. Okay. All right. So guys, the next part right here says making and interpreting decision. It says to conclude the hypothesis test, make a decision to either reject the null hypothesis or fail to reject the null hypothesis. The decision depends on your p-value and your level of significance, okay? So guys, in that handout that I gave you, I want to say that I copied the same part right here as well. But it says use a p-value to make a decision in a hypothesis test. We're going to compare the p-value with alpha. And there's a couple of pieces here. It says if p is less than or equal to alpha, we're going to reject the null hypothesis. If p is greater than alpha, then we're going to fail to reject the null hypothesis. Okay. Like I said earlier, guys, failing to reject does not mean that you have accepted it as true. Instead, there's not enough evidence to reject it, right? So like if I'm found not guilty, it doesn't mean that I'm innocent. It just means they didn't have enough evidence to convict me, right? Okay. If the claim is the null hypothesis, it's either rejected or not rejected. If the claim is the alternate hypothesis, it's either supported or not supported. So this right here, this little kind of chart, that's what you want to call it. You can kind of think about it as a little, something like this, is basically going to help me figure out how to do the next couple of problems, okay? So let's see. It says also if you're rejecting the null hypothesis, you're supporting the alternate. If you fail to reject the null, you cannot support the alternate, okay? So let's take a look here and let's see if we can figure this thing out. It says determine whether the claim represents the null hypothesis or the alternate hypothesis. How should you interpret your decision if you reject the null or if you fail to reject the null? Okay, so let's see if we can figure it out. It says a scientist claims that the mean incubation period for swan eggs is less than 40 days. Okay, so guys, do you agree we're going to write mu is less than 40 days? Okay. Everybody agree also that is our claim? Okay. So guys, what is the complement of saying something is less than 40? More than or equal to 40 days, right? Okay. All right, so we got that part right there. Now, next question, guys. Which is my null hypothesis? Which is my HO? The bottom one, right? So this is my HO, and this is my HA. Okay. All right. So now that we got that part, we're going to figure out this part right here. It says, how should you interpret your decision if you fail to reject the HO or the null hypothesis, or if you fail to reject if you reject the HO or fail to reject it. Okay, so guys, I'm just looking back at this piece right here. Okay, I'm not even going to worry about this right now because I don't need it. So let's take a look. If we reject the HO or fail to reject it, okay? So if I come back here, our claim in this case, our claim is the null or the alternate? The alternate. Okay, so guys, if I look at that handout that I gave you, my claim is the alternate, okay? If we reject the null, then what we would say is there is enough evidence to support the claim. So all I'm going to do is come back over here, because this is our claim, which is the HA, okay? If we reject the null, then what we're saying is there is enough evidence to support the claim. That's the answer, right? So basically going to be able to choose from what I have in that little box. Does that make sense? The wording is going to determine. So again, think about it this way. Our claim was the alternate, right? Our claim was the alternate. So if I'm rejecting the null hypothesis, right, and my claim is the alternate, then what I'm saying is there's enough evidence to support the claim, right? So let me come back. Let me take a look at the next part, right? So we can either reject it or we can fail to reject it. So right here, guys, I'm going to put fail to reject. That's right. Well, because, so there's two, basically there's two separate answers, right? One of them is if I reject it, the other one is if I fail to reject it, right? So if I fail to reject it, guys, again, all I'm going to do is I'm going to switch back over here. If I fail to reject it, look what it says. There's not enough evidence to support the claim, right? So that's all I'm going to write right here, guys. There is not enough evidence to, what, support the claim? There we go. We're doing the alternate, right? So my claim is my alternate right here. And if I fail to reject it, then we're saying there's not enough evidence to support the claim, right? So think about it this way. This is my claim, right? My claim is the alternate. And if I'm failing to reject it, then what I'm saying is there's not enough evidence to support the claim, right?
If the claim was HO, we would write down
The other part. That's right. That's right. And we're going to do that in the next couple of problems, guys. So think about it this way, right? So remember how we did this here? It said that the mean was less than 40. That was my claim, right? That's okay. That's okay. But do you see how the problem said the mean incubation time for swan eggs is less than 40? So the mean is less than 40. That's what they're claiming, right? And that happened to be my alternate. So all I did is I said, look, what happens when my claim is my alternate? These are the two things I'm either going to have. If I reject the null, then I'm going to say there is enough evidence to support the claim. If I fail to reject it, I'm going to say there's not enough evidence to support the claim, right? So look, I'm going to come back, I'm going to do the next one. So just make sure that we understand what's going on here, okay? Yeah, it's okay. Look, it's going to take a little bit of time, guys. That's why this section kind of breaks it down into small pieces, okay, to make sure we understand what's going on. So let's take a look here. It says the university publicizes that the proportion of students who graduate in 4 years is 82. Okay, so we've done parts of this before. Y'all agree that P is equal to 0.82? Okay, is that our claim? Okay, that's our claim. So guys, what is the opposite of saying something is equal to 0.82? Not equal to 0.82. Okay? Oops. 0.82. Okay. So, well, hold on. Let's go slow, right? Okay, which is my null and which is my alternate? The top is which one? Is null. So this is my HO. This is my HA. Okay. So let's take a look here, guys. The claim happens to be the null, right? That's my claim. Okay. So, well, hold on. Let's take a look. Let's not get ahead of ourselves. Okay. So look, guys, I'm gonna do one thing. The first thing I'm gonna say is, look, let's suppose we reject the null. Okay. So if I say, look, if I reject the null, then we are saying what? There is enough evidence to reject the claim, right? So that's all I'm going to write right here. There is enough evidence to, very good, reject the claim. Very good. Okay. Okay. So there's the first one. Okay, I'm just going to move it over a little bit over here, guys, to the side, because I got room aquí. That's right. So now look, our claim is still the HO. But now if I fail to reject it, look what I'm going to say now. There is not enough evidence to what? That's right. So if I fail to reject, right? If I fail to reject, then there is not enough evidence, right? let's see, to do what? Let me come back one more time. There's not enough evidence to what? Reject the claim, right? To reject the claim. Okay. All right. So now let's try number 12, okay? Number 12 says, Consumer Report states that the mean stopping distance on a dry surface for a Honda Civic is less than 136 feet. Okay, so the mean stopping distance, so guys, the mu is less than 136. You all agree that is the claim? Okay. So what's the complement of saying the mu is less than 136? Very good. Greater than or equal to 136. Okay? All right. Now, we only got a couple more parts to do. Which is my null and which is my alternate? The null is the bottom one. Very good. That's our null. Okay. This is our alternate, right? Okay, so here's my null. Boom. And here is our claim. Okay, so guys, the claim in this case is which one? The null or the alternate? The alternate. Okay, so here's, I'm going to be looking at basically this piece right here, right? Okay, so let me come back. That's all you're basically doing. That's all it is you're doing. That's all you're doing. That's all it is, right? It's basically, can you kind of stare and compare? Reject the HO. Sorry, that looks horrible. All right, so guys, can anybody tell me what am I going to put over here? What would I write under this one here? So reject. Okay, so let's take a look. Our claim is the alternate, right? Okay, so everybody agree because our claim is the alternate. We're going to be looking at this piece here? Okay. So my question to you, what am I going to put right here if we're rejecting it? There you go. Okay. All right. So then what would I put on this other side over here, guys? There you go. No, but I could have stayed home tonight. There is not enough evidence to what? Support the claim? Sorry about my handwriting, guys. I'm sorry? Let's see. Is that all of 7.1? Boom! We got that part done. Okay, so guys, let me stop this real quick.